Awesome. Well, thank you so much, everyone, for joining. My name is Anke Liu. I'm the Senior Program Manager of the Stellar Development Foundation, mostly focusing on the Stellar Community Fund, and I'm excited to start our panel today. So this panel will be about the Stellar Community Fund and mostly our reasoning behind community funding, as well as why we need a new voting mechanism, how we built it, and then as well as an overview of the design and implementation of the voting mechanism, as well as next steps. So I'm super excited to introduce you to our esteemed panel today, Danilo from Block Science and Alejo, who is coming as an engineer from the Stellar Development Foundation. All right, please introduce yourself.
So it's a pleasure to be here with Al, Danilo. I'm an atmospheric physicist by formation, engineer at Block Science, which is a firm for complex systems engineering. We are focused on performing economic design and validation over several projects. And projects that we've been supporting historically includes, for example, Filecoin, Gitcoin, and among others. And I'll pass the word to Alejo, which has been supporting us. And he will introduce himself.
Hi, everyone. I'm Alejo Mendoza. I'm leading the engineering efforts on the Community Fund. I've worked in past projects like Stellar Quest, Fast, Cheap, and Out of Control. Worked with a lot of engineers involved with Stellar since, I think, 2016. Very excited to be here. And yeah, this my short intro is also on, my background is on music production and engineering. So I'll pass it to Anke.
Yeah, it's so exciting, you know, like definitely having Block Science here and having you as part of the, being part of the community for so long. Even, you know, Stellar Community Fund winner, now working on the mechanisms of the Stellar Community Fund. It just fits. And so I just want to preface that today might go a bit fast. This has been the kind of the TLDR of months of work directly on the voting mechanism, as well as years of research and community feedback and experiences with other SCF voting mechanisms. So if you have any questions, definitely you can ask them to our panel later on. All right, but for those who don't know or need a refresher, the Stellar Community Fund is an open application awards program to really boost development for developers and startups building on Stellar and Soroban. So different from other programs at the Stellar Development Foundation, the SCF, which is an abbreviation, Stellar Community Fund, actually relies on community input for award allocation, review, support to projects, as well as governance decisions. So this year, we actually supersized the SCF to bootstrap the Soroban ecosystem, as you might have heard in other panels as well. Right now, award rounds run every 4 weeks instead of twice a year. And we also embedded a startup camp, a quarterly startup camp, to really provide accessible mentorship to projects. All right, so so far we actually have had 9 full review rounds this year. We awarded over $8 million to over 100 projects. So this is quite an achievement. I'm very excited about this, and we're continuing to run monthly rounds. So question to the audience here, who of you has been awarded by SCF or is verified? Please raise your hands. Wow, I'm so excited to see like such a, you know, like a tangible impact of SCF in this very room. All right, well, be proud of yourself. Thank you so much for coming. All right, so, you know, why community funding, just to preface. So we believe that, you know, distributing the allocation of awards is instrumental in building kind of constantly evolving and changing ecosystems, especially now with Soroban. It's like, yeah, it's really important to like identify the most promising projects when you have a more diverse set of eyes looking at a lot of different projects, as well as a scalable approach to, you know, build such a large ecosystem. This cannot just be done by a central or single entity. The community members right now in SCF, they help grow projects, they help support them, they give feedback. We have an active Discord as well where a lot of excitement and collaboration is happening. But yeah, finding the right voting mechanism and kind of finding the right coordination mechanisms, I think they're challenging, right? And I think over the past few years, it has been a little bit of a trial and error where we tried, a different voting mechanism here, from like kind of binary yes/no approach to more of a quadratic funding of voting. So that was also very interesting. But it has proven to be challenging. And as we kind of grow and as we kind of, especially now with the Sorbonne ecosystem trying to bootstrap all of the different projects, there's a big importance on making actually this SCF very successful, making SCF set up for scale. And we wanted to find the right voting and governance mechanisms to empower our community and so forth. So that's why at the beginning of this year, actually, we have been working with Block Science to design a whole new voting mechanism. I actually met with Kelsey from Block Science last year, if you remember, on the Sorbonne stage. Not here, I guess, in Madrid, but in Rome. Same stage, though. We started to talk about the intricacies of DAOs and also about, maybe SCF turning into one. Who knows, right? At some point. I think that was very exciting and really like kickstarted this talk of like, well, how can we get started? How can we collaborate? And that's when we started the conversation. So Block Science is a research firm. This is a complex problem. You've talked about it for a bit, but you're good at. Block Science is really famous for, solving complex problems in an innovative way. And I think this needs like an innovative look on how to actually make this for SCF and make it work. So I'm super excited. I'll hand it over to Danilo to kind of talk a bit more on how this voting mechanism came to be.
Yeah, thanks. So SDF has approached us on the beginning of the year, and we had some challenges back then, and we still have. And first one is about the SCF itself, because we want to have a voting mechanism that, would fit exactly the desirables that we would put to the community, but also we wanted to have a voting mechanism that would be stable, something that we could trust over time, that, if we need to have changes, they would be in terms of iterations rather than changing everything. And we also had another challenge, which is related to the launch of Sorbonne. And by the way, this is going to be the topic of the next panel, that we are going to talk about the governance modules library. And just to provide the landscape when we did start scoping that, because as probably you all know, the landscape on solutions for how you do votes, how do you adopt governance solutions on DAOs can be quite diverse. So here is a table. It's a simplified table, but provides some examples. Like there are several properties as the first column, like how do you assign weights to votes, what are actions associated with votes, how is the temporal dimension of the votes, and to the right on the elements, we have ways to characterize each one of those. So for example, weights. How do you assign someone's power? You have things like one identity, one vote, which is probably the simplest one. It's essentially direct elections. You have identity, you have one vote. You have other solutions like the one that Curve Finance adopts, where you lock an amount of token, and the longer you lock, the bigger your power is going to be. But it's also adopted by other solutions in different ways, like conviction voting. And also you have the notion that maybe not all identities are equal. Some identities are worth more because they have more reputation, they have more expertise. So those are some ways. It's not comprehensive by any means, but there are some ways on how you could set up those weights. Another dimension is usually on a voting mechanism. You are not talking just about voting to a project. You can also talk about other types of actions, like, for example, the idea that you can delegate your votes. So you can delegate your votes to another individual, or maybe you could delegate, and as we are going to see, we did adopt a pretty interesting solution for SCF that is based on groups. Also other types of actions. We can also think about vetoes, which is a distinct thing from voting. And other things like temporality, like you can have votes in batches. You can have votes that are continuous, where people propose and vote at any time. You can do retroactive votes. And outputs, because a vote can be yes or no, but also it could be number-based. And yeah, the reason why I'm showing that is just to make the point that the landscape is diverse. There are several solutions out there, and it's not trivial which one to select. And the way that we did approach in order to select one for SCF is really by following what we call the engineering design process. So this is a general way that we use for describing how we approach projects. And the idea is that for any system that is being implemented, you need to follow through several steps in order to make sure that the implementation is going to deliver on the intentions. The first step is really about collecting requirements, collecting desirables. And this would be phase one. Phase two is really about giving our desires, our requirements, our constraints. What are the solutions that is able to deliver on that? And there are two parts, because one is to map out the solution, a list of solutions that deliver on that, and the second part is to actually select the solution as per requirements and desirables. The third part is really about validation. So given data, given simulations that we build, given counterfactual scenarios, how do we make sure that the system is robust in delivering its intended requirements and desirables? So the way that we did approach the collaboration is we did take 1 to 2 months of ideation workshops where we did map out the requirements and desirables. And based on that, we did move to a module specification phase, where based on those requirements, we did ideate a solution, and we did validate that solution with SDF. And right now, we are on phase 3, which is the part related to implementation and validation. And so just to cover some of the results of phase 1 related to requirements and desirables of the voting mechanism for SCF, this would be a summary over the requirements. We are going to publish a blog post soon that enters into even more details. But the first 2 items that were quite obvious is that the voting mechanism should be effective and fair. Effective in the sense that we must be able to select projects that are going to generate value and impact, but fair in the sense that it recognizes each member individualities, its history, its reputation. Other requirements that, in my opinion, is a bit less trivial is, for example, the requirement of being scalable. And by scalable, we mean several things. We mean scalable in the sense that if we have a way larger volume of projects and members, the mechanism should be able to handle it. But it's also scalable in the sense that as we have grown on the community, we expect also diversity to increase. Diversity of projects, but also diversity of criteria that we are going to use to judge the projects, or criteria that we use for allocating power to the members. And a fourth property, which is transparency, is related to, it should be relatively straightforward to you to backtrace the voting results to the members' actions, in the sense that, it should not be a mystery why a certain project got voted for and got funded for. And also there are privacy concerns, which are being handled mainly on the implementation side. And the last 2, which I think there were some of the, in terms of being specific, they were the determinants to choose the mechanism that we did choose. First one is the flexibility, in the sense that, if we have new ideas on how to attribute power, it should be relatively robust on how you can create new forms to attribute power. If we are, because we do expect the way that we value projects and members to change a lot across time. So the voting mechanism should be able to handle easily those changes. It should be amenable to iterations, but in a way that doesn't discard the way that we did set the powers before. And the last one is about being innovative. like, because we are having the launch of the Soroban network soon, and at the same time, Soroban has several unique characteristics, and also, this is a voting mechanism for SCF. Stellar is a unique network, as we all know. So we wanted this mechanism to, both exploit those capabilities, but also to provide a showcase of them. And given the requirements, we can move on to the actual voting mechanism. And the name that we have given is Neuroquorum Governance. And this is an illustration. This is a summary of how it would work. So on the left, it would be a sketch of a user interface. And on the right, it would be a sketch of what are the actions and how powers are allocated and so on. So I'm going to unpack that. The term Neuroquorum Governance is actually a mixture because we actually designed two mechanisms. The first is what we call quorum delegation. And the second one is what we call neurogovernance. And I thought the phrase may seem a bit buzzy. We are going to see that this actually makes a lot of sense because neurogovernance, in a certain sense, its architecture resembles a lot how neural networks are implemented. And actually, the name neuro was an afterthought because we did notice the similarity after the fact. And quorum delegation is a mechanism that resembles a lot Stellar Consensus Protocol. And moving on to explain the bits. So this is first one, neurogovernance. So this is a mechanism for setting up weights. So this is a general framework that would allow you to take a user and say what is going to be his voting power towards a project. And some of the main requirement that was encoded on this architecture was the question of being flexible, being modular. Because it's, the idea is that each user, the way that the power is going to be allocated is you have those layers, and each layer contains a series of what we call voting neurons. A voting neuron consists of an oracle function and a weighting function. And the idea is that the oracle function is going to encode any logic that we want to provide, let's say, a RAM voting power. So let's suppose that we want to have a bonus that's based on a trust graph. Like we have an interface where you allow people to trust each other. And based on analysis of that trust graph by taking metrics, you want to assign a bonus that's associated with that trust graph. This would be contained inside the oracle function. And this would make up a neuron, like, for example, the trust graph neuron. But we could also have other neurons, like, for example, a reputation neuron. The idea is that reputation may, for example, you may want to have badges that expresses reputation on the system, and on the oracle function, you would have a logic that would put the data from an API, and based on the interpretation of those badges, it would have a RAM number. You could also do that for prior voting history. You have an oracle function that pulls the history and assigns a number. So the idea is, rather than trying to create a very complicated voting mechanism that encapsulates everything, what we are trying to do here is divide and conquer. We set up the base architecture, and we break down the way that you assign power to those neurons. And the idea is that by having those weighting functions, the maintainer of the voting mechanism, which we aim to be the community at some point in time, the maintainer of the community is able to set up the weights without necessarily needing to change the logic, which improves maintainability. And the idea is that each layer, you can have several neurons, and it's all going to be aggregated together. And the aggregator function, it's another decision, because, you can take the output of all the weighted neurons, and you can take a sum, you can do a summation, or maybe you could multiply them all together. This is defined per layer. And the output of each layer is also going to serve as an input for the oracle functions on the next layers. And the final user power is really what gets after the last layer. And And just to make it clear, on our first implementation, we are going to just use just one layer because this is simpler to explain, this is more intuitive, but we want the architecture to be robust to change. We do not want to change the architecture. We want to change the neurons. We want to change the weights. But as much as possible, we want to have this general architecture that allows us predictability. And also because developing a neuron is way simpler than developing a full voting mechanism. So we want the community also to take ownership and to develop individual neurons and so on. So this is also a way of creating opportunities here. So that was neurogovernance, which was how you set up vote power. The second one, which is quorum delegation, which is quite novel. And this takes a direct inspiration in Stellar Consensus Protocol. So this is a way of, because we know that a lot of members, they are very busy, or maybe they do not feel comfortable yet to judge across projects. So on those cases, delegation is an interesting type of action that allows you to funnel your attention and your power. Traditionally, delegation schemes, they have several issues, like they tend to be vulnerable to collusion. They tend to be vulnerable also by the actions of influencers. And we did come up with a pretty interesting way to do a delegation that would avoid those problems, which is rather than delegating to an individual, you delegate to anonymous groups of people. So each member is allowed to select up to 10 people. And this is an ordered list. So what's going to happen is that every round, a member can choose, does he want to vote or does he want to delegate? If he chooses to delegate, then what's going to happen is that on that list, you're going to delegate your core is going to be formed by the members that are voting. So there is no, redelegation is not allowed. Like you cannot delegate to a member that's also delegating. You can only delegate to people that are voting. So you select 10, and the first 5 users that are voting rather than delegating, they are going to form your anonymous quorum. So delegatees, they do not know that they are part of quorums. And those quorums, they are going to vote for the projects. It's going to be yes and no decisions. And depending on their agreement, an agreement we can think about in 2 ways. There is absolute agreement, of the 5 people on the quorum, 50% did actually vote. And there is the relative agreement, because users can abstain. And we need to make sure that we have, first, that we have a minimum quorum, active quorum, and second, that there is consensus on that quorum. And depending on the quorum results, the delegating member vote is going to automatically be set to yes, no, and abstain. So if there is consensus for yes and no, your vote is going to be yes or no. If there is no consensus, you are going to abstain. And yes, and this is the second piece. And I mean, the way that we did approach, we did create a specification for that, both in mathematical forms, but also in pseudocode as expressed in Python notebooks and so on. And the next step, which would be implementation, and we actually already have the smart contracts in Sorbonne for that, was implemented by Alejo. So I'm going to pass the word to him so that he can share all his learnings and experience implementing those 2 voting mechanisms. And here you are.
Thank you, Danilo. Is this better? Okay. All right, so we had a big challenge here. And we started to ask ourselves, is really Sorbonne ready for us to develop on top of? And for us, we explored different versions. We actually created 2 versions of the voting mechanism. One is written in Python. And we started to think, okay, can this code be translated into Rust code? And can we have the same features that we have here on the design specification? Can we translate those into Sorbonne? And surprisingly, the answer is yes. And not even that. We found that the experience as a developer is so fun, and that we can extend all this code into using Rust libraries and just creating whatever we needed for the voting system. So next, I'm going to explain a little bit about the architecture. So we tried a lot of different things. One thing that didn't work out at the beginning was to do a contract for everything, and just I would recommend this for you to not do this. Like, try to be as efficient as possible. Use the less amount of contracts that you can use, because this is actually going to have a toll on efficiency and scalability and cost. So we went for a very simple approach, which we have a main voting contract in which we expose all the API of our voting system through there. If you needed to set up anything there, set up your layers, add neurons, tally, everything goes through there. And then we have our Oracle contract, which is our data layer. This deals with everything that has to deal outside, from the outside world. So I don't know if you voted, if you're a verified member in the past, but all that voting data, we're going to be using it for our voting mechanism. With this, we can just like set all the neurons data on our Oracle contract and fetch it to compute the results. So it's pretty simple. As you see, we've got the front end that interacts with our TypeScript API layer. This was like a super interesting project to work on. Actually, we found out that that the SOAR1 client still needs, we still need more from the SOAR1 client, because when you build the bindings, we needed something that could run on Node runtime and not just for the browser. And so we kind of like had to tried patching that, but we went for the approach of just using Stellar base. We have our data, which is on Sanity. I don't know if you've used Sanity. They have their own data sets. They're called Content Lake, and their own query language is pretty extensible, easy to use. We can interact with the marketing team as well. We can reference data, content data. Here we can have project submissions, users, or past voting history can also be recorded there. And finally, with this API layer that is permissioned, pretty much private, and we kind of like pipe this into our voting system to interact with it. We have like all the functions you would need for the voting system to work, and also the external data provider. One very important thing on storage is that why did we take this decision on separating these two is because the voting system is going to have is going to be using storage instance, which is a little bit more long-term data, and our data provider is just going to have temporary data that we can just like set every round. So ideally, every round we would set the reputation that we grab from our Discord server, the voting history, delegation. If you are delegating to users, then we're gonna grab it from there, and the trust bonus. So that's it.
All right. Well, almost. So yeah, I mean, thank you so much for presenting. I mean, as you can see, this has been, you know, work of like just deep diving for months and months into lots of materials and elements and community feedback as well. And yeah, I just want to thank the team here for, you know, providing such more insight. And obviously, I imagine you have questions now. Now you got a flavor. It's like, what do you mean, neural quorum governments? That sounds interesting. I don't quite get it yet, but we'll release some more information soon. I also wanted to make a shout out to Giuliano from SDF, who has been advising this project, as well as our two contractors who have been actively building out these smart contracts right over there from, yeah, raise your hand. Yeah, thank you so much. All right, and so what's next? We had actually a bit more content prepared, but I'll go over it pretty quickly. So we are still in the implementation of building. So right now, we hope to have something later in October for you to test out. So definitely stay tuned, as well as some more resources and some blog posts to dive into. So next few months, what is that going to look like? We're going to calibrate, we're going to test a lot, we're going to see like, oh, maybe expertise weight should actually weigh a bit more than the trust weight, or, oh, actually not, and how does this change when the community grows, right? So there's going to be a lot of different factors that will influence, our, I guess, like the voting mechanism over the next few months, I would assume, before we can fully rely on it, but these votes, everything will be public, everything will be as much open source as we can do as possible, so that it's not only good for SCF, but also for anyone else who wants to make use of these voting mechanisms. Again, thank you so much for watching. I encourage you, if you want to get involved, become verified, scan this QR code. I'm not sure if it works on mobile, but you have the link in any case. And be part of this, really this growing ecosystem of innovation. And thanks again, and see you soon, hopefully. All right.
Thank you.